These are going to be equations that we do. This lecture note in particular focuses on things along the x-axis, right? So we're talking about horizontal motion. There will be another set of notes that will be in reference to vertical or free fall. So we have three kinematics equations. You'll notice that there are 5 different variables, v, v naught, a, delta, x, and t. This first equation is in reference to velocity as a function of time. The second one, it focuses on displacement, and this third one is velocity as a function of displacement. What's more telling about these is what they are missing.
Most impressive.
So may I suggest creating a table? We're going to put missing. And of course, recall that the 5 variables are going to be v, v naught, a, delta x, and t. You'll notice that the first equation is missing delta x. The second one is missing v, and the third one is missing time. In other words, what this last column tells us is that if I'm not looking for these things, then I'm not going to be using these equations that go with it. You will be doing what I call the 5, 3, 1. So always identify the 5, just list them, just write out the 5, and then decide on the 3 that they do give you. And then, so for example, they give you v, v naught, and a. And then you're going to identify the one that you're looking for. We'll make this more evident as we go throughout. In case if you missed the memo, by way of introduction, this is v naught. This is the same as the initial velocity. And v for us is the same as v final, as we've done before in the past. And this is the same as the final velocity. Delta x, of course, is displacement along the x-axis, left and right. Well, here are some common phrases that we find in these problems. A car begins from rest. This refers to v naught. And in this case, it refers to v naught being 0, right? It starts from rest. How long did it take? Do not confuse this use of the word long with displacement. This is in reference to time. So B is in reference to time. A horse slows down. Remember, this is a classic phrase for acceleration, right? But in this case, it's negative acceleration. It's what we call deceleration. A motorcycle comes to a complete stop. This is the final velocity, not to be confused with v naught, the initial, right? This was initial. This v is final, and it comes to a complete stop means that it's 0. So these two in particular, A and D, tend to be very common and popular, and they show up in a lot of problems. So be mindful of those. A runner travels a distance. This would be delta x. As it speeds up, we have again the opposite of C. Speeding up is a classic phrase for acceleration, and in this case, it's positive acceleration. A car is waiting for the traffic light to turn green. That means it's at rest. And that's its initial velocity, the v naught. Okay, so these are common phrases you're going to encounter. Problem 2. Let's list the 5 variables and their units. So we have v, v naught, a, delta x, and t. The units for v are meter per second. V naught is another type of velocity. It just happens to be an initial velocity. Nevertheless, it is still meter per second. Acceleration is just like before when we talked about Newton's laws, meter per second squared. Delta x, meters, and time will be appropriate for us as seconds. All right, solving for t. So we're going to solve the first kinematic for t. So recall that the first kinematic is v is equal to v naught plus a times t. We're going to get this t by itself. You'll notice that there is a plus separating these two terms. There are two terms, but when you have equations that are separated by pluses or minuses, you take care of those first. You take care of moving things with a positive or negative the opposite way. In this case, I have a positive v naught and subtract it from both sides. We're going to get the t by itself. So now what's happening is I have this t is multiplying by the a. The opposite of multiplication is division. We're going to divide by a. Make sure that we do that for the entire numerator. Not just v or v naught, but the entire thing is over a. That makes it so that the a's cancel out. I get t is v minus v naught over a. Part B, if we look at the second kinematic, delta x is equal to v naught t plus 1/2 a t squared, we run into an immediate problem. T is here and here. Unlike the previous problem where t only appeared once in the equation, in this equation it appears twice, and not only that, one of them is to the second power. These are not like terms. They cannot be combined because they have different dimensions. This is one-dimensional, this is two-dimensional. We cannot combine those two. In order to solve this equation for t, we would have to use what's called the quadratic formula. This will not be undertaken in this class, and so we leave this problem alone. We will, however, work with these equations, okay? We will only do special cases, but this is hard to work with. If v naught is 0, this whole term cancels out, and then it's easy to rearrange it, okay? Solve the third kinematic for t. It doesn't have t, so we're done. Take a moment to summarize. Summarize the process discussed in class for how to decide which formula to use. Hint, but explain it, right? Explain it.